Microbial biomass unlocked. Hi, my name is Alexandra Pavlik. I work at Wageningen Food and Bio-Based Research as a researcher, and today I would like to tell you more about a project concept on unlocking the potential of microbial biomass for nutritious food products. Our project team consists of scientific experts across different technologies. Luis, who is an expertise lead in protein technology, Martijn, who is an expertise lead in microbial cell factories, Jurian, a senior researcher in nutrition, quality and health, and Joost, who is a program manager. A little bit of a background behind this project. We all know that global demand for protein and lipid is ever increasing. And this is driven by the population growth, but also a shift towards more sustainable diets. If we want to address this need with conventional food production, we know it's going to be challenging, and it's going to result in overexploitation of resources and environmental degradation. Microbial biomass from bacteria, yeast, microalgae, and filamentous fungi is a new, sustainable, low environmental impact protein and lipid source, which can be efficiently produced locally and have a higher potential to contribute to future food security. A key selection criterion, however, for such novel sources of protein and lipids is their techno-functional properties in food application. We have identified that a challenge for primary and secondary food producers is that there is insufficient knowledge on how fermentation parameters, for example, media or side stream composition, but also microbial strain selection, will influence the functional and nutritional properties of microbial biomass for application in high-quality food products. The aim of this project is to identify those key drivers in biomass production, which will allow for good quality and nutritious food products. We have reasons to believe that this is a promising research approach. For example, recent results submitted for publication from the group of Julia Kepler from Wageningen University Food Process Engineering suggest that macromolecular composition and functional properties of bacterial biomass can be indeed steered by optimization of cultivation conditions. This results in different properties of this biomass in meat analog applications. To address the mentioned knowledge gaps, we propose an integrative approach across the whole value chain. Based on scientific hypotheses which will be built by WFBR and this consortium partners, we will design a set of experiments to clarify the role of factors that play a role in biomass functionality. Those factors are species selection, for example, strains, substrates, fermentation conditions, and possible mild post-harvest processing, such as cell lysis and fractionation, as the combination of those factors will affect the biomass nutritional composition, but also physical-chemical properties, and allow their successful application in good quality food products. We propose an approach with work packages which are focused on specific part of the overall challenge. So in work package 1, the biomass production is the focus with selection of microorganisms, media composition and process conditions, but also potential downstream processing. Next, work package 2 will focus on product and how biomass as such, but also mildly fractionated biomass, can be used in defined product formats. Those product formats may be dairy or meat analogs, but also truly innovative product formats. After incorporating the biomass or its fractions in food products, in work package 3, we will assess the digestibility and bioavailability of those biomasses and the influence of the food matrix. Finally, in work package 4, we will integrate the learnings across the value chain and also address the regulatory aspects of the selected scenarios. In more detail, the aim of work package 1 is the production of biomasses under controlled conditions. Ideally, such biomasses are produced at partner facilities following a selection of species, for example, bacteria, yeast, fungi, or microalgae, selection of media, and process conditions. Those process conditions can be monitored, for example by NIR or Raman, to track the process performance, but also to determine the cause of batch-to-batch variability, which is often experienced by the producers. It is possible that such fermentation is conducted by WFBR. As a consortium, we will decide if and how we want to apply downstream process to potentially boost the functionality of biomass as a structuring ingredient, but also making this biomass more digestible. Once the biomass is produced, in Work Package 2 we will assess its functionality in product matrix. This will involve first the compositional analysis of various biomasses and its fractions. We will also then define the food model systems that are of interest of our partners, for example dairy or meat analogs, or really truly innovative food products. Then we will define the quality criteria, for example taste and texture, and finally we will use those biomasses and their fractions in selected model food products and assess their quality. Selected good quality products will be then further analyzed in Work Package 3 with the aim to assess their digestibility and uptake. Impact of food matrix on digestibility will be made by comparing it with biomass only and fractionated biomass digestibility. We intend to use the InfoGest protocol, which was developed for lipids and proteins by WFBR. For the best performing solutions, the digest can be applied to gut epithelial cells to assess the bioavailability. And optionally, the gut health and safety, for example, allergenicity, studies can be conducted if this is of interest to the consortium partners. Finally, in Work Package 4, we want to take a wide-angle view and integrate the learnings and results across the whole value chain. This will allow us to identify the key drivers and also trade-offs in the biomass production process, which result in good tasting but also nutritious food products. This work package may have an iterative link to other work packages, which will depend on the timeline and the budget. And if it is of partners' interests, we will also landscape the regulation and legislation aspects of application of microbial biomasses in food products. What we hope to deliver with this project is the identification of the key drivers for end product quality, defined as textural quality but also digestibility, in biomass-containing formulations. We will also validate process analytical technologies for tracking process performance and batch-to-batch variation, and we will integrate the learnings across the whole value chain, from biomass selection and fermentation to post-processing, food matrix composition, and in vitro digestibility. As this is only a project concept, we really hope to shape it together with you for the most relevant outcome. Please reach out for more details. Thank you for your time.